What is up YouTube? Welcome back to another episode on CodeWIthAni, and in this episode we're going to continue looking at the collections framework, and today's collection will be set. Okay, so set is a special data structure in Java which is known for having only unique values saved in it. So if you try to insert a duplicate element into a set, it will simply not accept it, it will ignore that addition. Okay, for example, here I have initialized a new set by implementing the HashSet class. Okay, I'm saying new HashSet. Okay, there are two more types of set which I'll talk about in this video quickly. So let me get started on this. So the first thing you need to observe is, as soon as I say set space a set equal to new hash set, if I go into the new hash set, right, see what is happening within. It is saying map is equal to new hash map. Okay, now this gives you a very important concept, underlying concept which you need to know, is that the hash set or any other implementation of set internally is backed by a hash map implementation. Okay, you can see here constructs a new empty set. The backing hash map instance has default initial capacity 16 and a load factor of 0.75. What it means to say is a default hash map is created with size 16 and it will keep expanding as and when you keep inserting elements into the hash map, into the hash set, because internally it will insert into the hash map, right? And this hash map is nothing but a hash map of e comma object. Now what is this e? The e is nothing but the data type that is specified in this angular bracket for the set. Okay, because set is a value driven data structure, meaning it will only deal with homogeneous single values, like for example a set of integers or a set of strings. The hash map is basically a two data type data structure, right? It deals with two data types, one is a key, one is a value. So the value for the set is actually the key for the hash map, and the value of the hash map is nothing but a dummy object that is created to just put something for the key. Okay, we are not interested in this object at all when we are trying to retrieve the information from a set, because when you try to get the element of a set, the get method itself is not there in the set. I'll tell you the reason for that as well. But what is actually returned is nothing but the keys of the map when you try to retrieve the information from the set. And now what is a unique property of a map? A unique property of a map is, as I've discussed in the overviews section of collections, it has a unique key and a non-unique value, right? And what did I tell about set? Set always maintains unique insertions, right? That's, now you can draw the correlation, right, between why a set is backed by a map, right? It is backed by a map because the keys of the map are unique, and the set is a data structure which will only accept unique values. Okay, that's the reason why when I try to insert 10 elements into the set and I try to print out the set, you can see that values are printed out. Let me try to run this again. I'll show you that it prints out the entire set. I add another element to it. I again try to print it out. Let's see what happens. In both the cases, it only prints the existing values. It does not add this element 5 to it. Okay. Now if I were to add another element to it, let's say 10, this will probably go into the set. Okay. See? So only unique values that are not already present in the set are considered to be added to the set, because the map, that is the backing map within the set, will only allow unique keys to be added, right? So that's the beauty of the set data structure. And here you can know that there is a small caveat, right? I mean, map is not part of the collections, not a caveat per se, but it is an irony that map is not part of collections, but map is a data structure that set, which is part of collections, is using for its underlying operations, right? So there's that. And with that out of the way, you don't have a get method for the set. I cannot say a set.get because set does not have an index based operation, unlike a list, right? A set will be using the hash map, and hash map uses the hash table data structure to save the information within itself. Therefore, I'll talk about all the different underlying data structures and binary trees and everything in a different playlist called as data structures and algorithms. So there I will discuss in detail about problem solving, time complexities, and as well as pointers like hash tables and binary trees and graphs and other important data structures, but more on that in a different playlist. For this one, just letting you know that there is no get method on the set. You cannot get an element out of the set directly, like you do it in a map, or like you do it in a list as well, right? Like you do it in array. That is one of the reasons why set is not very widely used in real programming. Most of the times you'll be using list or array list implementation of the list. Okay, not even linked list. Most of the time it's going to be an array list implementation, right? Now HashSet is just one implementation of the set interface, right? You have two more. Okay, one is called as LinkedHashSet. Okay, and one is called as TreeSet. So these two are other two implementations of the set interface. LinkedHashSet, because the normal HashSet implementation does not have any insertion order, right? When you put elements into the set, right, it will be inserted randomly. Okay, when you try to retrieve them, sometimes if you try to print this out 100 times, right, the order in which this is printed out will change. Sometimes you will say 0, 1, 3, 2, 4, 5, 6, 7, 8, 9. So the order might change. I may not be able to show it here because it happens randomly. But what I'm trying to say is the order in which you put the elements into the set is need not be the order it maintains behind the scenes. Okay, it will be different. If you want the order to be preserved, you need to use the linked hash set. Why? Because the linked hash set uses a doubly linked list behind the scene to link all of these integers or all of these objects together. So when I insert 0 and insert 1, the doubly linked list will make sure that 0 is connected to 1 and 1 is connected to 0. That's why it's called doubly, meaning it makes sure that A is connected to B, B is also connected to A. Okay, not one way. It's going to be both ways. Likewise, when you insert 2, 1 is connected to 2, 2 is connected to 1. Okay, behind the scenes. Which is one of the reasons why linked hash set is slower than the normal hash set, because it is trying to maintain the lineage or the linkage between different elements in the set. Okay, but it does help you preserve the order in which you insert the elements into the set. So when you retrieve them, it will always be retrieved in the same order. Okay, the order will not change. Likewise, TreeSet is a special set which implements a tree data structure within, and it makes sure that the elements that you insert into your set, right, are always sorted. Okay, let me show you an example for both of these. Okay, if I change this to linked hash set, I think it should still be fine. Okay, if I run this, you can see that it's the same thing mostly, because the randomness is very rare to show, so you can see that it is the same thing. But I'll tell you an example for TreeSet. Okay, let's say set of integers space a TreeSet equal to new TreeSet. Okay, now at TreeSet, let's try to insert some elements into this one. Okay, for I equal to 10. No, probably will not use the for loop because it's gonna retain the order. Okay, we can use the for loop as well. Let's try from I equal to 10 and we'll go all the way up to I greater than 0. I minus minus. I'm just inverting the for loop. I'm saying that I'll start with 10. I'll keep decrementing 10, 9, 8, 7. I'll reach till I value is greater than 0, which is 1. So from 10 up till 1, I'm going to put that into the tree set. Okay. Exact reverse of what I did above in the other for loop. Okay. Now let me try to print out the value of the tree set. Okay, let's say south TreeSet. Let me try to run this. Now I'll show you what happens now. Right? See what happens here. I tried to insert the elements in the descending order, correct? I tried to put 10 first, then 9, 8, 7, but see what it has printed out. So as soon as you keep entering the elements into the tree set, it will try to sort those elements in the ascending order by default. Okay, that's because it internally uses a binary tree to sort it, but I'll talk about trees and other data structures in a different playlist, as I already mentioned. Just know that a tree set will always keep your set sorted no matter the order in which you insert the elements. If it's an integer or if it's a string or whatever it is, it's going to be sorted in the ascending order. Okay, likewise, a linked hash set will always preserve the order in which you insert it. Okay, not sorted. It will not sort it. It will just preserve the order in which you insert the elements into the linked hash set. And a normal hash set doesn't give a shit about either of these two properties. It is going to just save the elements into the backing hash map. All of these other two implementations also use a hash map for saving them. But apart from the hash map, they additionally linked hash set additionally uses a doubly linked list to save that information, and TreeSet just uses a tree to sort the data in ascending order. Okay. So I hope this video is clear, explaining about the different implementations of set, why set is in picture, and why it does not have a getter method. It does not have a get method because it's not an index based operation out there. Okay. Hope this video was helpful to you guys. Hit the like button if you haven't already, and subscribe to CodeWIthAni. And I'll see you guys in the next video with another collection. All right. Bye bye guys.